All right, in this video, we're going to look at writing a system of equations. We're going to work on creating equations to fit a scenario described in a word problem. I'm going to do 4 examples in the video. To start out with, I'm going to do a scenario that only requires 1 equation. Our first example is talking about a recording studio. A recording studio charges musicians an initial fee of $50 to record an album. Studio time costs an additional fee of $35 per hour. We're being asked to write an equation that gives the total cost of an album as a function of studio time. So, key parts of our example. We're being asked to write an equation that gives the total cost of an album as a function of studio time in hours.
Still needs their pictures taken. You can have your pictures taken in room 209. Any other students who have not had their pictures taken, please do that. This is the last call.
So to start with, I'm going to build a verbal phrase to model our situation. I want to write an equation that gives me the total cost of recording a studio album. And that total cost is made up of 2 parts. We have the cost per hour, and we have the initial cost. So this is what my equation is going to look like. Now, to go from the verbal phrase to our algebraic equation, I need a couple variables. I have 3 parts here, and 2 of them can change. The initial cost is always going to stay the same. The number of hours to record an album could change. You know, your album could take 5 hours to record, it could take 10 hours. And as the number of hours changes, the cost will change as well. So I need 2 variables. I'm going to use an uppercase C, capital C, to represent my total cost. And then, because our cost per hour, I'm going to use a lowercase h for the number of hours it takes to record the album. Here's my 2 variables. So let's go from the verbal phrase to the algebraic equation. Total cost is a capital C, which is equal to our hours, and it's $35 per hour. So I have 35 times the number of hours plus our initial cost is $50. So there is our equation. All right, let's look at our second example. So our second example, scenario talking about a web server. The initial fee to set up a website is $48. It also costs $44 per month to maintain the website. We're being asked to write an equation, the total cost of setting up and maintaining a website as a function of a number of months. So my verbal phrase looks like this. Again, we're looking for a total cost. Which is made up of 2 parts. We have cost per month and our initial fee. Again, we have 2 things that can change: the number of months we want to maintain the website, and the total cost will increase as the months increases. So 2 variables. I'm going to use a capital CN, total cost. Because we're doing it per month, I'm going to use a small m. Remember, all right, let's build the equation. We're going our total cost, C, is equal to, it's $44 per month, plus the fee is $48. And there's our equation. One thing to note, these first two examples, both of our equations being in the form of y equals mx plus b. Though the variables are different, however, we should be able to recognize the shape. So if we were asked to graph these, you should be able to see the similarities. Cost is equal to 44 times m, 48. Well, it looks just like plus mx plus b. This would be our slope. Is the cost changing? Well, it's up $44 for every 1 month it goes over. And our b, what's our initial amount is $4. All right. Here's our first example where we're going to construct a system of equations. And all that means is we're going to have more than one equation. In this case, it's going to be two. This scenario is talking about exercise. In this scenario, we want to burn 400 calories in 40 days of exercise. For weight and our exercise, and we burn 8 calories per minute eating and 16 calories per minute swimming. We want to know how long we should spend doing activity if we want to hit this number of 400 calories in 40 minutes. So we are making two equations here and our targets. In our first two examples, we were interested in the total. For these equations, we want our total to be 4 calories, and we want to hit a total of 40 minutes. We're going to have one equation because we want a total of 40 minutes. Our equation, we want to burn a total of calories for calories. So we're going to model these two situations. These are totals. Now our variables, two things: the number of minutes we swim and the number of minutes we skate. Now swimming and skating both start with S, so use X and Y. I'm going to let X equal our minutes that we skate, and I'm going to let Y equal the minutes I swim. Okay, so we have our variables. I'm going to add the verbal phrase and construct an equation for each of these. First, minutes. We want our total minutes to equal the number of minutes we skate plus the number of minutes we swim. So our total minutes, we're going to exercise for 4 minutes. The number of minutes we skate, well, that's represented by our X, plus our minutes we swim is represented by our Y. 40 minutes to number of skates, the minutes we swim. And Y, so when you fit, you might have to do one step to change that equals mx plus b if you want to use that to graph. An equation talking about calories. Again, our verbal are going to look similar. We have our total calories equal to the number of calories we eat. So our total calories is 400. Calories. Well, we have to see how many calories do we burn every minute we eat. 8 times number of 8 plus a variable for every minutes we swim. How many do we burn? 16. So 8 minutes we skate plus 16 times the number we swim. This is our equation for our. Now, to finish this section, graph both of these. Find the x and y intercepts and graph it that way, or reach them with y from x plus graph them that graph these and then find the section. Then just building the equation. All right. Relay just $50 for labor on car repair. Has charge diagnosis $30. Engine repair is the same at okay. Yeah. So I know how long the car equations. First equation going to be for Smith. Smith second equation is going to be for Liz. Lopez. So we have two things changing: the hours for labor, and we need the cost. Now the cost is both the fees. H for hours. Smith, it's pretty straightforward. $50 per hour for labor, and that's it. So the cost is equal to $50 times the number of hours. There's our equation. If I wrote it as a verbal, we'd have the total equal to 50 times our numbers. So in this case, the verb phrase is very different than our actual happening here. $, times our total is equal to Lowe's Ford is charging $40 per hour. They have a diagnosis fee. This diagnosis is like you're checking the car out when you go to the doctor. Something you have to pay before they do any work. Just look at it. Diagnosis fee. Initial fee. Total, we're going to use a capital for Lopez, $50 per hour, plus 30. All right. So we built the equation. We would graph these, and then the point where the cost is the same, how many hours it took. And these are both in y